Hi, welcome back everyone for part two of the spring final exam 2024 review. Um, so today we're gonna start off with the stuff that we did in the fourth 9 weeks, so in this past 9 weeks. So it shouldn't seem too unfamiliar, too far away because we just did this not even not even 2 months ago. So this stuff shouldn't be crazy. All right, so starting out with rationals. So remember, that's that funky stuff. It looked like a fraction. There was x's in the top and the bottom, and it was crazy, but we're going to talk about the stuff that you specifically need to know for this final. Starting out with attributes. Things like horizontal asymptote, vertical asymptote, domain, and range. Now for this, don't even need to pull up Desmos. We can figure this stuff out from here. So starting out with the first function, my horizontal asymptote. Okay, now from this equation alone, I can find the number that is going to be the equation for my horizontal asymptote. And that is the big number that is either adding or subtracting on the outside. So here that -6, that -6 is my horizontal asymptote. That will give me that my horizontal asymptote is y equals -6. Okay? Bless me, guys. So then vertical asymptote, I'm going to look at this number in the bottom. This x minus 4 situation down here is going to tell me my vertical asymptote. And it's going to be a little different because it is going to be x equals +4. So remember to switch the sign. It's not going to match exactly what you see in there. Okay, so if you need to write down this example and make a note of that to yourself, please do so. All right, and now domain and range. So domain is all of our x values. That was really ugly. Domain is all of our x values, so it's going to be tied to the vertical asymptote. Okay? And some of you might remember this is the long and funky way of writing domain. We start with -infinity. Okay, we have the u. We end with +infinity. And what's going to go in the middle? This number, that 4. And that's how we write domain. For range, since range is all of our y values and our horizontal asymptote is y equals, it's going to be tied to the horizontal asymptote. So it's going to be very similar to domain, where I've got -infinity, comma, something, parentheses, union, parentheses, something, comma, +infinity. Now what's going to go there? The number that I see with the horizontal asymptote, that y value where I have that horizontal asymptote. So in here is going to go a -6. All right, let's try the next one. So horizontal asymptote, starting out with that one, y equals -1. Okay, vertical asymptote is going to be x equals -4. So even though that's an x plus 4, remember that I switch my signs. And it's x equals -4. Going on to my domain, remember that my vertical asymptote is giving me the domain. So it's going to go from -infinity to -4. And then from -4 to +infinity. For my horizontal asymptote, from -infinity to -1. and then from -1 to positive infinity. Okay, that's how we find these specific attributes of a rational function. Great. Now we move on to dividing rational expressions. Now this is the one where it was a bit funky, a little bit more involved, because it did require us to factor a little bit before we even got to divide. So I want you to remember that first, when we see something like this, I don't know why it's getting funky. When we see something like this, we factor by using the x, the big old X. And what's going to go in the X is the -18 on top, that last number on top, and that middle number on the bottom. And what I'm looking for is two numbers that multiply to -18, and when I add them together, it gives me 7. So, what are my numbers? Well, they are 9 and -2. And you'll have to mess around with this a little bit. Play with Desmos, play with the calculator, see what are numbers that will multiply to make -18, but will also add to make 7. All right? Not that this is going to be the exact problem. I'm just saying, like, whatever numbers you have, just mess around with it a little bit. Okay, so these two numbers, the 9 and the -2, are important. All right? The other thing that we are gonna have to factor, let me pick a different color. Let me do yellow. Is this thing, the 10a minus 20. Now, when we see 10a minus 20, it's not quite so complicated. But when I look at 10a and 20, what do those two terms have in common? Well, they are both divisible by 10, meaning I can take a 10 out here. And what am I left with? I'm left with an A. Oh, and that's a -20. My bad. And so I'm left with an A, and I'm left with a -2. So what does this mean? All right, so now I'm getting to the point where I'm rewriting this whole expression that I started with. So I'm going to change out this 10a minus 20 to 10 from here and a minus 2. So I took this, I did this, and then I rewrote it like this. So I have 10 times a minus 2 on top and a 10 on the bottom. I still have the division sign. Then here, okay, I took this, I did this, and now I'm going to use that to rewrite this. I'm going to have a plus 9 and a minus 2, and then a 10 on the bottom. Okay, haven't divided yet. All we did is rewrite things, factor things, so that way when we divide, it's super satisfying and things cancel out. So what am I going to do now to divide? I am going to keep my first fraction the same, not doing anything to it. I'm going to change this division to multiplication, and then I am going to flip this second fraction. So what is that going to look like? I've got 10 a minus 2 over 10 times 10 over a plus 9 a minus 2. Now, what do you see that's the same on both the top and the bottom? Well, I have tens on the top and bottom. Those can cancel out. Not this one. Okay. They travel in pairs. Okay. They need to cancel out in pairs. So just this one and this one cancel out. And then I see an A minus 2 in parentheses and an A minus 2 in parentheses down here in the bottom. All that I am left with is a 10 on top and then a plus 9 on the bottom. And so that is my answer. Okay, so I need you to write an example of you factoring something like this, and then this whole entire process. I need you to do that. And if you have any questions about this, please ask me. Right? The dreaded word problem. I know we hate it. This is the one that we had on our Unit 11 test. Literally. Okay? So, this, you're going to see an inverse variation problem on your test. It's going to say varies inversely. I swear. I swear to you, I would not lie to you about this. It is going to say varies inversely. Now you need to pay attention to what it says before and after varies inversely. So the formula for inverse variation is going to be y equals k over x. This is for inverse variation, which is, of course, the one you're going to see. I can't spell. All right. Now, here, cost. All right. That first thing they're talking about is going to be the first variable. So in this case, y is going to be my cost. Then the thing that comes after varies inversely is going to be my x, my second variable, number of people. So I've got that my cost equals k over people. Okay? So that's my first step. I want to figure out what my formula is going to be. My second step is going to be to find k. All right? So they tell me that if 40 people, okay, those people, pay $9.50 each, that's their cost, to ride the chartered bus. What is the cost per person if only 25 people go? Ignore that now. I'm just using this 40 and this $9.50 to figure out k. All right? So said my cost was $4.50. Okay, I don't know what that is because I'm trying to figure it out. P is the number of people. How am I going to get k alone here? How am I going to figure it out? Well, I'm dividing by 40. So I have to do the opposite of dividing by 40 to get rid of the 40 over here and get it to the other side. Opposite of dividing is multiplying. And so if we use a calculator to do that, it's $380, by the way, just in case we didn't know. So 380 equals k. Cool. So now I move on to my last step, 3. Now that I figured out what k is, I'm trying to figure out what the cost is. What is c when p, the number of people, is 25? Let me circle it. Okay, so I don't know c now in this last question that they're asking me. But I know that k is 380. I know that p is 25. And so I use a calculator. 380 divided by 25 is 15.2. So the cost per person is $15.20. Word problem. Yay. Okay. Oops. Another word problem. Now this is literally from your homework from this unit. So if some of you are like, I've never seen this before, you're a liar. Or you're not a liar, but you just weren't paying attention when I did this in class the first time. Because everyone was confused on this one, and I worked it out on the whiteboard for everybody. So I've done this before, but I'm going to do it again so that you guys can have this in your notes to use on your final. So it takes your rival school 18 hours to deliver the food baskets. One round of food basket, 18 hours for the rival school. Now, if your school and your rival school work together, it's going to take 8 hours. How long would it take your school to deliver it alone? Okay, so here is the information that they gave us. Rival school, to do one round of basket delivery, it takes 18 hours. Something to remember with a rate, and in your test you're going to see it like this. It's going to be number of something over time. Time is always going to go on the bottom. Please do not put 18 on top. Then your school, you don't know how long it takes your school yet. You're trying to figure that out. So if you don't know something, you use X to represent that. And then together, they did tell us how long it takes together. They can do a round of food basket delivery in 8 hours. Well, what am I going to do with these fractions? I am going to create an equation. So the equation is just the two parts add together to make the total. Yeah? Now, to figure out what x is, I have to get x alone. Now, x is in a fraction, so we just need to get this fraction that has x in it alone. What's on the same side as it? The 1 over 18. Move it to the other side. Here, this is going to cancel out. All right? And here is where we are going to use Desmos. Please hold while I switch. So now that we're in Desmos, you can type 1 over 8, and then use that arrow to get out, minus 1 over 18. Okay, and yes, this is giving us a decimal. Disgusting. This button here will give us the fraction. Okay, 5 over 72. So, 1 over x equals 5 over 72. Well, x is still a fraction. I want to get this out of the fraction. All right, now this only happens in this type of problem. Do not apply this to literally to all math problems that are like this, because it doesn't always work out. But in this case, it does. I want to get x out of the denominator, and I just have a 1 in the top. The easiest way to do it at this point, I only have one fraction on each side of the equal sign. I can just flip the fraction. Okay? And anytime I divide something by 1, it is just itself. Dividing by 1 does not do anything to change the value of the number. So our answer is x equals 72 over 5 hours. Or if you wanted to be special and put it in decimal form, 72 over 5 is 14.4 hours. Okay? And this is our answer. So I want you to, A, get comfortable doing the setup part, making the fractions from the word problem, and then setting up the equation, and then solving for x. These are things that if you know at least part of it, you can get partial credit even if you don't get the multiple choice part correct. Okay, moving on to the lesson, or the lessons, what am I going to say? The unit that we pretty much just finished. We've only spent a week in this new unit. We have spent the most recent amount of time in cubics and cube roots. So let's get started. All right, attributes of cubic functions. Let's head to the Desmos. My main thing about this is showing you guys how I want you to show your work for this. Now, realistically, when you work out the problem like this, it is going to be multiple choice, and you're kind of just going to be matching it to the correct graph. I don't really mind too much how precise your work is. I think the first one is it's the +8 one. So when you do this, what I want you to do on your paper, so what I draw in pink is going to be what, if I were you, I would put it on my paper. I would not, this is what I would not do. Do not just put Desmos, graph that matched. I despise when you guys do that. And I do not give you credit whenever you put that down. Never. Never do I ever give you credit for that. Because I hate it so much. Because that doesn't tell me anything about what you know. So what I want you to put, I want you to draw an image of the graph that you saw. And I want you to put that when you typed that in, that it looked like this. Tell me that you looked for the intercepts that matched. I would prefer that than just saying the graphs matched. That doesn't tell me anything. But if you tell me that you were looking for the intercepts and it matched the correct spot that you were looking for it to match, that shows that you're being a little more thoughtful and intentional with the answer that you selected and you didn't just randomly guess. Okay, so something like that. I would love if I saw a quick little sketch like that on your paper. That would be great for me. And let's say it was -8. So pay attention, right? Like pay attention to what you're typing because this two different things. Two different things. But I want you to just draw the picture. Okay, it's a quick question. Just draw the picture, please. Okay, just tell me that it matched. Tell me that it matched. The intercepts matched. Draw a picture. Do not say Desmos or graph matched. I'm not going to give you credit for that. Do something like this, like what I drew in pink right here. Okay, something like that. All right. On to cubic and cube roots as inverses. All right. Okay. So kind of like what we're talking about with the logarithms, I'm just going to go through the whole opposites thing. Okay, so first, I want to look at the original, things that I'm seeing in the original. Okay, so what I'm seeing a cubic. Okay, I'm seeing the parentheses with the exponent of 3. That is a cubic. All right, Then I'm seeing a 4 multiplied inside. All right, I want opposites. I want opposites. Well, I'm not going to write opposites. I'm going to say inverse. Okay, but the inverse is just looking for opposites. So what's the opposite of a cubic? Cube root. Okay, cube root is the opposite of a cubic. And then instead of a 4 multiplying inside, I'm going to have a 4 dividing outside. Okay, so what is the inverse going to look like? I'm going to have this, the f with the -1. Remember that that means inverse. What does it equal? All right, I'm going to have the cube root symbol. And inside, I'm going to have the x. Because the x just always goes inside. X lives on the inside. And a 4 divided outside. So you may think that you're going to see it like this. You're not. Technically, that would be correct. Okay, so if you decided to put that down on your paper, I can give you credit for it even if you get it wrong. What I want you to recognize is that you're not going to see it like that. You will see it like this. A 1/4 on the outside. And I need you to recognize that that is the same thing. Okay, so this is the inverse. Yay! And so we're going to do the same thing with this other problem. My original has a cube root. Cube root. Oh, my bad. A 4 divided inside. And so the inverse. I'm going to have opposites. I'm looking for opposites. Okay, opposite of a cube root, cubic. Opposite of a 4 dividing inside is a 4 multiplying on the outside. Okay, so my inverse, again, that -1 means inverse. I'm going to have the parentheses with the 3. X is going to live inside. X loves to live inside. Okay, and then a 4 being multiplied on the outside. Now, sometimes when you see it like this, you don't have to have the parentheses because there's nothing else inside there with it. So another way you might see it is just like this. Okay, but this is our inverse. Hooray. All right, solving cube root equations. Solving equations, remember, is about getting x alone. And getting x alone starts with getting the stuff away from it that's furthest away from x on this side of the equal sign. All right, so on this side of the equal sign, I'm trying to get the stuff away from x that is the furthest away from it. So that would be this 12. Now this 12 is positive. This negative is not part of the 12. The 12 is separate from that. So to get rid of a 12 like that, I'm going to subtract 12 from both sides of the equal sign. So here they cancel out, and I've got negative cube root of 5x minus 3 equals, and you could use a calculator for this, 9 minus 12 is -3. Okay, now I want to get rid of that negative that's outside of the cube root. That's disgusting. I hate when a negative's outside of a cube root. I'm going to divide by -1 just to get rid of the negative. Just to switch it. Just to switch that sign. And so now instead of negatives, it's all positive. Okay, I just switched the signs, really. That's really what ended up happening. Okay, and now to get rid of a cube root, I have to do the opposite of a cube root, which we just talked about in the previous problems. It's a cubic. Okay, the parentheses with the 3 up there. That's going to take this away. So I've got 5x minus 3 equals 3 to the 3rd power. If you use the calculator, that is 27. Okay, I'm just going to move this over here so we have more space. I'm just, I'm continuing because we're not done. Now, gotta add 3 to both sides. Okay, to get rid of this minus 3, I have to do the opposite, which is plus 3. So I have 5x equals 27 plus 3 is 30. Sorry, let me be consistent. And then I divide by 5 on both sides. And so I get x equals 6. And that's my final answer, that x equals 6. Hooray. And finally, the stuff that we just talked about this week. Radicals, the roots. Starting out with rewriting radicals with rational exponents. We are not even simplifying them. You are just rewriting them. Okay, so what you have to know is that this number in the bottom is going to be that little number outside of the root. Okay, little number outside the root, little number outside the root. So if it is a 2 on the bottom, then little 2 on the outside, except we never do that. It's like, it's just a square root. Okay, it is just a square root. All right, here, I'm going to have a 4th root. I'm going to have something that looks like a square root, but instead of just being a plain old square root, it's going to have a little 4 on the outside. And then that number on top. That number on top stays being the number on top, okay? It's the exponent. And so here and here, I'm just going to have a 3 there. I'm going to have a 3 here because I have a 3 on top of this fraction exponent. And then yes, that stuff on the inside stays on the inside because we're not going to simplify it in this final. We're simply rewriting it. And if you did your Delta Math assignment for the first lesson of this unit, you should be familiar with just rewriting it. Okay, so that's all we have to do here. Elite. Solving radical equations. Okay, I think that we did a problem almost exactly like this first one in class. Except the 7 and the 25 were in different spots. But we are going to go ahead and move through this one. Alright, so first, I have to get x alone. What's the furthest thing away from x on this side of the equal sign? This minus 25. And to get rid of it, I'm going to do the opposite of minus 25. I'm going to add 25 on both sides. Why does this thing hate me? Help. Okay, plus 25. So then I have 4x to the 3 over 8 equals 32. Okay, so I divide by 4 on both sides. Hooray. Okay, and I have x to the 3 over 8 equals 32 divided by 4 is 8. Now, to get rid of that fraction exponent, I take it to the reciprocal power. Or, in less fancy words, I take it to the power of that fraction, but flipped. Okay, flip that fraction. The reciprocal power. So here, that cancels it out. And I've got x equals 8 to the 8 over 3. I'm not done. Have to simplify it. Okay, so what I'm going to do is I'm going to rewrite this 8 to the 8 over 3. Let me delete this line so I have space. I'm going to have the cube root of 8 to the 3rd power. To the 8th power, JK, because that's an 8 on top. And we literally just talked about this in the last couple of examples. My bad. I'm going to simplify this cube root of 8. Right, so 8 is 2 times 4. 4 is 2 times 2. So really, this is the cube root of 2 times 2 times 2. And if you recall our little jailbreak analogy, a cube root, to get simplified, for this stuff to come out, needs 3 friends to get out of jail. 3 friends. We got 3 friends. So 2 gets to break loose. So really, this is just 2 to the 8. And if you plug that into a calculator, it's 256. Okay? If you take this equation and you plug it into Desmos and you just draw a picture of the graph where the line goes through it, you are not getting credit for that. You need to work it out. Please and thank you. So the next one, let's see it. I add 8 to both sides, following in that same pattern. Okay, I've got 2 times x to the 4 over 5 equals 32. Yet again, crazy. Then I divide both sides by 2. So I've got x to the 4 over 5 equals 16. And I want to get rid of that 4/5, so I take it to the 5/4 power on both sides. Wow, I swear we did this in the notes. I feel so dumb. I literally took this from the note slide. Guys, what a world. So then I take this and I rewrite it as 4th root of 16 to the 5th power. Hey, taking that 16, breaking it up a little bit. That's 2 and 8. 8 is 2 and 4 is 2 and 2. So really, what is 16? It is 2 times 2 times 2 times 2. And since this is a 4th root, we are looking for 4 of the same thing to jailbreak. To take out a 2, I have to have 4 of the same 2 on the inside. So then I've just got a 2 free jailbreak. And then it's to the 5th power, and that gives us 32. Hooray. You've got this, okay? I think that you guys are very capable of getting every single question right if you watch these videos, okay? You have to take detailed notes, and you only get out of this what you put into it. All right, so if you finish these notes before the day of the final and you want extra practice, go ahead and come find me and get a review packet, because I will have a review packet ready to go that will have more practice questions for you to practice on your own and make sure that you understand how to apply what you've done in the notes to actually working out a problem. Okay? Good luck!